Good morning, Math 3 students. I wanted to go through some more lessons, some more focus, and we finished off by talking about how functions were transformed and how you can see that just from the coordinates that are given to you from the function. So on the next, I believe, 2 pages, you've got 4 more to work on. I'm going to do 2, and I'm going to help you kind of see the other 2. And that's our big goal for today. So, as we get started, a big process for us to go through is first to see the change in the coordinates. Once we see the change in the coordinates, we could write down the change in geometric notation, and then finally think about how that change affects our function notation. And so that'll be the process that we go through. We're not going top to bottom. We're just looking at the coordinates, finding out the change, thinking how that gets written in one notation, and then how that gets written in the equation itself. So to start out, let's take a look at this. If you look, the original values are right here. Here are the x's, here are the y's. So if we come over here, the x's are right there, and the y's are different. So the y's have changed. That's my daughter. Okay, the y values have changed. And specifically, the y values, you can kind of see, oh, maybe you added 3/4 to get there. Maybe plus 3/4. But for this one, that's not plus 3/4. 1/2 plus 3/4 does not equal 2. So we're not adding the same amount. Turns out we are multiplying the y values by 4. 1/4 times 4 is 1. 1/2 times 4 is 2. So you can see that each one is multiplied by 4. Okay? Now, if we multiply, that's a stretch, and because it affects the y values, this is a vertical stretch. So this is a vertical stretch by 4. Okay? Now let's talk about the geometric notation. Our geometric notation is usually written like this. We have our x, y, and then we put an arrow, and that goes to the new x and y. Now, x doesn't change, so we leave that just as x. But the y does change, and specifically the y is multiplied by 4. So we can just put that down, 4y. Now, once again, if we multiply the y values, we always do that outside the equation. So if you're thinking about the function notation next, this is the first image, so we'd say f(1) of x equals, and you see that 2x right there, but outside that function, we're going to put the multiply by 4. So it ends up being 4 times 2 to the x. That is our equation, our function notation, okay? If it's the x values, we put it inside, and we always do the opposite in our function notation. But if it's the y values, we do it outside, and we do the same thing. All right, let's go on to the next one. As you can see, again, the x values end up being the same. But the y values are different in that they add a negative to each one. And let me make that a different color. The y values have a negative attached to each one. So, as you can probably assume, this is multiplied by -1, multiplied by -1, multiplied by -1, -1, -1. Now, you could say that this has a vertical stretch just like the last one. It's got a vertical stretch by -1. But there's a much better name for that. Whenever you have a vertical, a negative value vertically, it really just flips it. So this is a vertical flip. Okay? We flip the x, or we flip the y coordinates. It's just a vertical flip across the x-axis. Okay? A vertical flip across the x-axis. And we are multiplying it by -1. So up here, we would go x, y, with an arrow going to x, doesn't change, but the y becomes negative, so we put -y. There we go. And then for our function notation, it's the y value, so we do the same thing in our function notation. Again, just a reminder, if it's with the x values, we do the opposite. If it's with the y values, we do the same. And keep on picking a new color there. F2, because this is the second image of x, equals 2 to the x, and outside that, we put our negative. And we could put -1 if we want, but negative or -1 multiplying by each is the same thing. All right, so let's go on to the third one. Need that highlighter. If you take a look at this one, from the original graph, we're looking at this one and comparing it to this. So from the original graph, the y values are actually the same. It's the x values that change. The x values have changed. Rather than -2, it's -3. So it looks like that one is -1, but let's make sure it works for the others. It's -1 to -2, -1. 0 to -1, -1. 1 to 0, -1. 2 to 1, -1. So all of the x values are moving 1 to the left. So this ends up being left 1 unit. Left 1. All right, so what does that do to our equation? Well, up here in our geometric notation, we've got xy translates to x minus 1 comma y. So the xy translates to x minus 1 comma y. And this is our third image, so it's f3 of x equals... Now, this one's kind of different. Because it affects the x values, it's not going to happen to the outside of the function like the y values is. It's going to happen to the inside of the function, specifically where the x is. So rather than 2 to the x, we're going to put 2 to the x, and then we could put -1, but we've talked a few times about how it's the opposite. We always need to do the opposite if it's the x value, so it should be x plus 1. All right, and that is our geometric notation, our function notation for problem number 4. Now, for problem number 5, I'm going to let you guys do that one yourselves. Got a nice example here. You can just work on the one below it. And we're going to go on to number 6. I know you guys have a little bit of trouble with the trig functions because they were pretty new and we left before we took the test for it, but I do want to go over that a bit. So, let's get to it. All right, starting out. As usual, you want to look at the original x and y coordinates. 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, comma -1, 2 pi, comma 0. Okay, that's our original values, and let's see how they change in each of the images. And this time, we're going to get all the changes first before we write the geometric notation, and then finish off with the function notation. Okay, so if we look at this one, all the x values stay the same, but the y values end up changing. So if you look at those y values, those have all changed. It's not 0, 1, 0, -1, 0. It's 2, 3, 2, 1, 2. So if we look at those y values, each one of them is changing, and specifically those y values, each time they're adding 2. Plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. So because it's happening to the y values, that's vertical, and the plus tells us that it's a shift. So it's a vertical shift up 2. All right, let's go to our second one and get back to that highlighter. Here we go. Let's see if there's any of the same ones. The y value, 0, 1, 0, -1, 0, that is the same. It's the x values that have changed this time. So those x values have changed on this one, which means that we can talk about the transformation in the x values. Well, it doesn't look like we added or subtracted anything because 0 plus something would not equal 0. it looks more like we multiplied by something. So it's hard to tell what you multiply 0 by, because 0 times anything is 0. But if we go to pi over 2 times what gives me pi over 4? And it's actually times 1/2. Times 1/2. Times 1/2. Times 1/2. So each one here is changed by 1/2. Now, 0 times 1/2 is 0, so that pattern is going to stay even up on the top. And this tells us, because it's happening to the x values, it's horizontal. And because we're multiplying it by 1/2, that's a compression. This is actually a horizontal, you could call it a shrink or a compression, depending on, I believe, your teacher last year. But this is a horizontal compression by, you could say by 2 or by 1/2, but I'm going to say by 1/2 because we're compressing it by a factor of 1/2 because that's what's going to go in the equation. Okay, now let's go to the third one, see if there's any changes. 0 for the x coordinate, 0, pi over 2, pi, 3 pi over 2, and 2 pi. That stays the same, but the y coordinates are the ones that change this time. 0, -2, 0, 2, 0. So looking at those y coordinates, how did they change? That is our next question. So the y coordinate was 0, and it went to 0. So that kind of indicates that it's going to be multiplication. And it went from 1 to -2. So just right away, that looks like a multiplication by -2. And if we see about that pattern, -1 times -2 is +2, because a negative times a negative is a positive. So multiplied by -2. And I'm going to change these multiplication symbols. I can't handle that. They look like X's. There you go. Put the multiplication dots there. All right, n times -2 here, because 0 times -2 still equals 0, so that definitely does work. So this one actually contains 2 transformations. Because it's with the y coordinates, it is both vertical. This is a vertical flip and stretch. Now the stretch here is by that 2. The negative tells us it's a flip. The stretch is by 2. Okay? Vertical flip and vertical stretch by 2. So that actually gives us 2 transformations that you would want to do on a graph, but we're not really focused on the graph right here. All right, let's go through our geometric notation. XY transforms into, well, the x doesn't change, but the y just adds 2. Here, XY, and the x changes this time, so it's going to be 1/2 x. You could also write x over 2. That's the most common way to write it. And then we also have xy, which gives us x -2y. All right, and then finally, for our function notation, I'm going to pick the best color here, green. We'll do some function notation. Remember, if it happens to the y coordinate, we do it outside the function. If it happens to the x coordinate, we're going to do it paired with the x, but we always do the opposite in our function notation. f1 of x, f2 of x, and f3 of x. Okay, we got 1, 2, and 3. All right, now for f1 of x, or f of x, or the first image, we have sine of x plus 2. Outside the function, we're just adding 2. For the second one, remember we have to do the opposite, so it says times 1/2. Instead, we're going to multiply by 2. This is sine, and since it's the x value, we have to pair that opposite one with the x. All right, and then this one is multiplied by -2. It's the y value, so we're just going to put -2 times sine of x. You could put parentheses around sine of x. either way, it still makes sense. There you go. So we've got our geometric notation and we have our function notation. I'd really love for you guys to do number 5 and 7. Try it out on your own. Get the transformations that you can. With that said, I'm going to say have a good day, and if you have any questions, don't hesitate to post them in the comments or respond to me through email, anything like that. Thank you so much.